Dynamic wireless charging for electric vehicles is one of the solutions considered for resolving the issues related to the reduced range and the slow recharging capabilities of such vehicles. The Fabric European Project Consortium, consisting of 24 partners from 9 EU countries, has worked together for the past 4.5 years in order to investigate on-road wireless charging technologies as means to address users' range concerns and to make electric vehicle use more efficient and attractive. The project developed and evaluated the performance of different on-road wireless prototype systems. It also assessed scenarios for wider rollout of such systems, including their impact on the transport infrastructure, on the supply chain, on the electricity network, and of course on the environment. Finally, Fabric derived recommendations for deployment in urban, peri-urban and motorway situations, including cost and life cycle analysis.
To achieve its objectives, the Fabric Consortium developed 3 prototype wireless charging solutions and support ICT systems which were demonstrated in 2 different test sites, located in France and Italy.
The dynamic wireless power transfer solution integrated at the French research institute Vedicom was based on a market-available static wireless charging system provided by Qualcomm Halo. This system was modified to meet the requirements of on-road dynamic charging. Vedicom built an experimental reconfigurable track enabling charge at 100 km/h on 100-meter portion. In this track, the infrastructure part of the prototype was installed. The car part of the system was integrated in 2 Renault vehicles, in which Vedicom added measurement equipment and control systems. Many demonstrations showcased since March 2017 charge at 20 kilowatts, charge 100 km/h and charge with 2 cars. Later on, Vedicom performed complete characterization and assessment of integrated system for the Fabric project.
2 additional dynamic wireless power transfer solutions were developed and demonstrated at the Italian test site in Susa by Polito and site partners. A series of 50 multi-winding transmitter coils were installed at the 100-meter road segment on a Polito site, and 25 simple single-turn transmitter coils were installed on the road segment by site. 2 systems have been eventually demonstrated in a realistic road embedment.
Numerous test activities have been performed at the 2 test sites, evaluating the system's performance at several speeds, including various misalignments between primary and secondary coils and air gaps. The charging prototypes have been successfully demonstrated on several occasions, and valuable measurements have been collected to assist the Fabric analysis.
The Fabric analysis showed that dynamic wireless power transfer appears feasible in the medium term for urban deployment of buses and long-distance freight corridors. Implementation of e-road systems is technically feasible in current road design with currently available materials and will not significantly impact the electricity grid. Careful planning and gradual e-road deployment is needed. E-road construction procedures must meet current highway design and construction specifications, and Fabric has proposed business models for infrastructure owners and authorities.
Looking at all these valuable outcomes, we can conclude that the Fabric Consortium succeeded in delivering a complex and challenging project, including several innovative solutions. Although Fabric's main focus was the visibility of on-road wireless charging technologies, today we have witnessed important technological achievements with regard to static and dynamic wireless charging. I'm pretty sure that this will be considered as best practices and valuable input for future developments.